In this recording, I will provide an overview of sets and subsets. A set is a collection of objects. For example, I can let capital B equal the set that contains 1, 3, 5, 7, 9. 1, 3, 5, 7, and 9 are elements of set B. I used what's called the roster method when I just listed the elements. Another method for describing sets is just using words, the word description method. I could just state that B is a set of the first 5 positive odd integers. Another example, I will let W equal Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Note that the elements in the set are separated by commas. And this is the roster method. I could use words to describe the set. W is a set of the days of the week. Here is another example, set C. Note that set C is the same set as set B. That is because repetition doesn't matter. These two sets are the same. Order, the way we order them doesn't matter, and repetition doesn't matter. And I should mention that capital letters are often used to name sets. And next, we'll take a look at some notation. I have set A using the roster method, A, E, I, O, U. Set A has 5 elements. And E is an element of A. This notation here means an element of, whereas P is not an element of set A. The empty set is a set that has no elements. We can write it in 2 different ways. Here with brackets with nothing inside, and this symbol here is for the empty set. The cardinality of a set is the number of distinct elements in a set. And here is one way of notating cardinality. The cardinality of set A is 5. There are 5 elements in set A. And this notation can be used also. N of A is 5, the number of elements in set A. And set C, the cardinality of set C is 5. There are 5 distinct elements in set C. And we'll look at some other sets of numbers. N is a set of natural numbers. Z is a set of all integers. Q is a set of rational numbers. And remember, rational numbers include all real numbers that can be expressed as a fraction, A over B, where A and B are integers, and the denominator, B, is not 0. And R represents the set of real numbers. The superscript plus is used to indicate the positive elements of a set. And so, for example, Z with the superscript plus, that is the set of all positive integers. And remember that 0 is neither positive nor negative. And likewise, a superscript minus, that represents the negative numbers. So R with the superscript minus stands for the set of all negative real numbers. And again, 0 is neither positive nor negative. And so there are two ways so far of creating sets. One way is using the word description. For example, S is a set of states whose names begin with the letter A. Set S using the roster method would look like this: Alabama, Alaska, Arizona, Arkansas. Set builder notation looks like this. We do use the curly brackets, and then we start usually with a variable. Here it's X with a vertical line. You can also see it, instead of a vertical line, you can have a colon. And here it says X is a U.S. state whose name begins with the letter A. So we have our variable and then either a vertical line or a colon, and then we describe what the variable stands for. And that is called set builder notation. For example, set O here is written in set builder notation, where O equals a set X such that X is a positive odd integer. If I were to use a roster method for set O, it would look like this. Subsets. Set A is a subset of set B, expressed as A with this symbol, B. So this symbol here stands for subset. So set A is a subset of set B if every element in set A is also an element in set B. For example, if I have B equal to the set 1, 2, 3, 4, 5, and A equals a set 2, 3, 5, well, every element in set A is in set B. So it follows that A is a subset of B. If I have C equals 1, 3, 5, 7, C is not a subset of B because C has the element 7 and B does not. Couple of rules. Every set is a subset of itself. It's because it follows the rule as defined here. Set A is a proper subset of set B, expressed like this, so we don't have the line underneath it. If set A is a subset of set B and set A and set B are not equal. What that really means then is that there are fewer elements in set A than there are in set B. Every element in set A is in set B, but set A has fewer elements. So for instance, in these examples over here to the left, I could have used that notation. This notation is fine because A is a subset of B, but I could have been more exact and said, well, A is a proper subset of B. The empty set is a subset of every set. So for example here, still using set B, the empty set is a subset of B. And next we'll take a look at Venn diagrams. First, the definition of a universal set, U, is a set that contains all the elements being considered in any particular problem. In a Venn diagram, the universal set is represented by a region inside a rectangle, and subsets of the universal set are depicted by circles or ovals. For example, U is in the rectangle, and that represents the universal set. And both A and B are subsets of U. We'll do an example. The universal set U contains all the elements, including the ones not in set P or Q. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And that is a universal set. Set P equals 3, 6, 9. And we will note that P is a proper subset of U. If a set is a proper subset, it's also a subset. I could have just said P is a subset of U, and that would have been correct also. Q is a set containing 2, 4, 6, 8. And Q is also a proper subset of the universal set U. And as a reminder, every set is a subset of itself. And the empty set is a subset of this universal set. The empty set is a subset of every set. And it's a proper subset of every set that's not itself, that's not the empty set. In this case, we see that set A is completely within set B. This would mean that set A is a subset of set B. And of course, both sets A and set B are subsets of U. Or a Venn diagram can look like this. A and B are both subsets of U, but they are separate sets. And thank you for watching, and let your instructor know if you have questions.